Hello, this is Beth Rosengrant.
I'm going to start with problem number 5 because I already had it up on my GeoGebra and I didn't want to have to find those points again. The name of this quadrilateral is a parallelogram. And it is a parallelogram because parallelograms have two sets of parallel opposite sides. And this has two sets of parallel opposite sides. Number 1. I put these 3 points on and I'm supposed to find 3 other answers such that a parallelogram is formed. The first answer I found is 0, 0, 5. 0, 5. When you do the measurements, you can see that the two sides work. So the first spot that I did is 0, 5. Now I'll try the next one, which is 3, 2. 3, 2. Spot. Sorry, I need to do a point. 3, 2. That again makes a parallelogram, or forms a parallelogram. Take that away. And now we're gonna do the next spot that I found is -1, 4. Point. -1, 4. And that also makes a parallelogram. A parallelogram has opposite sides that are parallel and opposite sides that are congruent. If you want to measure the sides to make sure, we'll go into measurements. Side DB is 3.6055 and side AC 3.6055. You can also look at DA 2.2367 blah blah and BC. So actually this could be a square as well because it has 4 equal sides. Okay, hold on. I found the 3 points, the 3 points by looking at what was missing and how it could make a parallelogram, and then I did the measurements to see if they were equal measurements. Number 2, I'm going to plot my points. -5, wait, I gotta move this over here. -5, 2. -5, 2. -2, 3. -7, 8. Then we gotta change this. I always do this. -7, 0.8. And then found H to make a rectangle to be -4, 9. And that makes a rectangle where there are 2 sides equal, 2 pairs of equal opposite parallel sides. 2 sides, 2 pairs of equal opposite parallel sides. I knew that I needed to find equal length sides to get 2 equal opposite parallel sides. Number 3, I am going to make a triangle with -6, -3. I need a good point. -6, -3. -4, -5. -4, -5. I'll go back to point. And -2, -1. What type of triangle is this? Let's do segments. And then I'm going to measure them to find out what kind of triangle it is. You can see that A to C is 4.47213569, right? The same for A to C and B to C, so they're exactly the same size. That makes one angle greater than 90 degrees, one obtuse angle two equal sides. So it's an obtuse isosceles triangle because the two sides are equal and one angle is more than 90 degrees. For number 4, we're supposed to find the equation of the circle whose diameter has the endpoints 2, -5, and 8, -1 to show my work. So I took the 2 and the 5 and the 8 and the 1 and plotted it into this formula, midpoint formula. And I came up with the two midpoints, 5 and -3. And then I plotted them into the equation of the circle. Put the 2 here. Oh, you can pick either side. You can pick this one or you can pick this one. And I picked these points and put them into here, and that turned into 9 plus 14 equals 13, which gives us 13 is the r squared. So the equation of a circle is the x minus 5 squared plus y minus -3 equals 13, because we found out the radius is 13 squared. 13 squared.